Hello everyone, my name is Jin Yang and I'm presenting our paper, ERICA Query Refinement for Diversity Constraint Satisfaction. This work is motivated by the fact that with the increasing awareness of the importance of diversity and representation, many companies, educational institutions, and other organizations around the world are focusing on developing their diversity recruiting strategy. For example, many universities are encouraging people from marginalized backgrounds to apply. Fellowship programs often require a diverse pool of nominees, and the NFL's Rooney Rule mandates that the teams interview at least one candidate from racially or ethnically diverse backgrounds for senior leadership positions, although it does not dictate the final hiring decision. In this context, relational databases are frequently used to select candidates, and it would be natural to state diversity requirements as cardinality constraints over the presence of some demographic groups in the result, like inviting a certain number of individuals from different demographic groups for job interviews. Unfortunately, such constraints are currently not supported by relational systems, as shown in the following example. This table shows a dataset of 14 job candidates applying to a tech company with 4 attributes: gender, race, college major, and GPA. Major and GPA are the qualification attributes that may be used directly as part of the selection process. Gender and race are the sensitive attributes that denote membership in demographic groups, and in order to avoid direct discrimination in the decision-making, they are not directly specified in the selection conditions of a query. However, to counteract the consequences of historical discrimination, sensitive attributes may be used to state cardinality constraints for the result site. To invite applicants with technical majors and high GPA for an interview, the tech company used the following query. It selects applicants with a major in computer science and a GPA of at least 3.85. Candidates number 2, number 9, and number 10 are selected by this query, as highlighted in the blue color. However, this result does not meet the diversity requirements of the company. Only one female applicant is selected, although half of the applicants are female, and no Asian is selected, although white, black, and Asians are all present in the applicant pool. In order to improve diversity, the company would like to interview at least 2 female applicants and at least 1 applicant of each race. Additionally, to avoid overwhelming the human resources department, the total number of selected candidates should not be more than 5. These requirements can be expressed as a set of cardinality constraints over some groups in the query result. In order to satisfy the cardinality constraints, the company may slightly adjust some selection criteria. For example, they add electronical engineering, EE, as an accepted major to select more female applicants. However, this would expand the result site to be beyond 5 candidates to the interview, as highlighted in yellow color. Then the company refined the query again by restricting the GPA to be at least 3.90. Query Q3 is the refinement that satisfies both per group and total cardinality constraint. To assist the decision maker in refining their queries, we present ERICA, a system that generates minimal query refinements to satisfy cardinality constraints on groups in the result. Users give their dataset, original query, and some cardinality constraints. ERICA will generate provenness expressions, which will be used to validate whether a potential refinement satisfies the constraints without re-executing the query. ERICA will use a searching algorithm to efficiently search for all the minimal refinements, and return them to the user. By minimality, we mean that the refinements are closest to the original query. For more details of Erica, please refer to our paper. Next, there will be a demonstration of Erica made by my co-author alone.
Meet Erica, an interactive system that proposes minimal modifications for selection queries to have them satisfy constraints on the cardinality of multiple groups in the result. Let's see how it works. First, choose the relevant dataset for your query. We have preloaded several datasets, or you can upload your own data. In this demonstration, we will work with the student's dataset. It contains demographics and grades of students in Portuguese high schools. This data can be used by a policymaker to decide, for example, which students should be invited to speak with a guidance counselor to advise them on which colleges to apply to. If you are not familiar with the data, click the preview button to see its contents. To start, let's enter a query that will select students who should speak with a guidance counselor. First, we enter the selection conditions. Select students with good grades, both grade 1 and grade 2 are at least 13 out of 20, who are between 15 and 18 years old, and who express an interest in going to college. Next, let's add some cardinality constraints on the query results. We would like to select at least 30 female students and at least 15 students from rural areas. This is to make sure that students from these groups receive information about colleges and are encouraged to apply. Finally, the total number of students should be no larger than 100, because we have a limited number of guidance counselors who can speak to students. To define a constraint on the total result size, we use asterisk equal asterisk lower than 100. Click the Submit button and see your SQL query and its results. You can also see the counts per group and check if the query result satisfies the cardinality constraints. For this query, we have 100 students returned in total. 46 out of them are female, so the first cardinality constraint is satisfied. However, only 13 students are from rural areas. This does not satisfy our requirement that at least 30 students from rural high schools receive college application guidance, and so we will ask Erica to refine the query for us. Let's look at the refinement that Erica computed by navigating to the Show Refinements tab. There are 5 minimal refinements found by Erica, and they all satisfy all constraints. The blue color in refinements indicates a change in the selection condition compared to the original query. For example, the first refinement changes the selection conditions on grade 1 to be no less than 14, and on grade 2 to be no less than 12. It also changes the higher education intention condition to select students who may or may not have an intention to go to college. As another example, the second refinement changes the same values of grades, but instead of changing the higher education intention condition, it changes the age condition to select students who are from 15 to 20 years old. Next to each refinement, Erica shows its result set in comparison with the result of the original query. New tuples selected by the refinement are highlighted in green, and removed tuples are highlighted in red with strike through. Erica also allows us to sort refinements by different properties. For example, we may sort refinements according to the extent by which they change a specific selection condition. Here, we're sorting by the extent by which the condition grade 1 larger or equal than 13 was changed. We can see that the first refinement does not change this condition at all. The next refinement changes it by 1 point, that is grade 1 larger or equal than 14, and the last refinement changes it by 2 points. This helps the user to find a refinement that best suits their preference. For example, If the user wants to satisfy the constraints by modifying the condition on grade 1 as little as possible, they will choose the top-ranked refinement here. The user can also sort refinements by other properties, such as change in the group cardinalities and in the overall result. Hope you enjoy Erica. We would be happy to hear any feedback you have.